Extreme Physics.
Let's talk about electrical meters. Here I have a piece of electronics. It's actually a tuner, an FM tuner. And you can see it's got a bunch of parts in it. We got some resistors. There's that big can is like a capacitor right there. Am I on camera? And we got a bunch of capacitors, transformer, a whole bunch of stuff. And if you're designing something or fixing something, you're going to need to be able to do some measurements. You're going to be able to measure voltage, current, and resistance even. Let's talk about current meters and voltage meters. Here's two types of meters. This is called a digital multimeter, and it's got a digital display in it. I'm not sure how well you can see that. And we can measure voltage, DC voltage, alternating current voltage, DC current. It can do all kinds of things. This is right here, this is an old analog meter. It's also a multimeter. You have this knob here, and you can measure voltage, current, resistance. So you could see that I could take this, and you should be able to see the meter going, I think. And if I connected to the battery, this is a battery for some video equipment, and it's supposed to be at 7.4 volts. There we go, and we can see the meter going up, and it's going all the way. It says it's more like 8, right? So you see the meter go up. Hopefully you saw that, and we could also connect it to this one. And let's see what it reads. We're on DC volts. And 8, also 7.95 volts is what it's reading. All right, so we can measure voltage. And voltage is an easy thing to measure. Let's say I had a simple circuit like this. I had a battery and I had a couple of resistors like that. R1 and R2. And let's say I wanted to measure the voltage across R2. It's the potential difference from here to here. And I would literally just, I would take my two probes and I would literally just measure the difference between here and here by pressing on either side like that. So all I need to do is go like that, and that would measure it. And the same thing in here. I could just go, and if I wanted to measure the voltage across that resistor, I would just touch on either side of it, and it would give me the voltage reading. So measuring voltage is easy. You could just probe around and measure the potential difference between different points in a circuit. Measuring current is trickier, and that would be difficult in stuff like this. You actually have to get in there and do a little surgery to measure current, because if I want to measure the current in this resistor, I actually need to open the circuit up, because I need to actually put the ammeter in series like that. Here's my ammeter, like that. And if to use the real meter like that, what I would have to do if I had a circuit like that, I would actually have to open the circuit up. So somehow I may have to unsolder something or somehow take something apart. And then I would put one probe on one side and one on the other, and the current would go in one and out the other, and the meter would be in series, right? So to measure the current, I would connect an ammeter like that, and I put an A there to stand for ammeter. It's not amp meter, it's ammeter. And to measure the voltage, though, it's easier. I don't need to open it up. I just need to connect on either side of it. This is called a parallel connection, because there's two parallel paths that current can go through here or can go through here. This is called a series connection because we got one object after the other. An ammeter is connected in series. Now, because they're connected this way, and because we don't want the meter to change the behavior of the circuit while we're measuring things, right? The ammeter has to have a very low resistance, has to have zero resistance, really effectively zero resistance. An ideal ammeter has zero resistance. A real ammeter has some resistance, but it's really low. Because when you put it in there, you don't want it to lower the current that was happening in there. And a voltmeter, on the other hand, needs to have an infinite resistance, because we had current going around like this. We don't want, as soon as we connect this circuit, to have current traveling through the voltmeter. Now, in reality, a certain amount of current does need to travel through the voltmeter, and it's not exactly zero resistance, but a good voltmeter, a good voltmeter has infinite, very high resistance compared to this, and an ammeter has very low resistance compared to the other objects in the circuit. All right. In your notes, you have a diagram that looks like this, and we can see that we have a battery, and it's drawn like a battery. This isn't a schematic diagram. This is, again, like an artistic one. We got a battery. In order to connect an ammeter, the ammeter actually has to be in series with the circuit, right? I want to measure the current through here. The current's going to flow through here. The current actually has to flow through the ammeter. So when this circuit started its day, it was just a battery and a light bulb, and there was just a wire connecting these two together. We had to actually open this up and connect our ammeter. And so ammeters are more difficult to connect than voltmeters, because you actually need to open up the circuit. And because the current has to flow through the circuit, the resistance of an ammeter must be very, very low. And in fact, an ideal ammeter has a zero resistance, because if it had significant resistance, it would affect the current in the circuit, and the meter cannot affect the behavior of the circuit. Otherwise, it's not a very valuable meter. So there you go. And an ammeter measures the current through the wire. Notice it's not an amp meter. The P is dropped. It's just AM, short for amp, and then meter, ammeter. And this needs to be connected in series in order for that to work. There we go. And there's our current going through. And here is a drawing more like you would do, or in a diagram. If you do an electrical diagram, you draw a battery. It looks like that. And here's our ammeter. Wire goes in one side of the ammeter, comes out the other. Then it goes into the load. In this case, it's a lamp. A light bulb goes in one side, and current goes around and then out, and like that. And we got a complete circuit. And there you go. And here is our equivalent water circuit, right? We got, instead of the battery, we got a pump, and then our ammeter is just like this little paddle wheel where it's real easy to turn, right? The water comes through, it spins the wheel, and that affects the dial up here, so you can tell how much water is flowing, and then it goes through the circuit. All right, a voltmeter measures the voltage drop or rise across a component. Now, this is easy. These are much easier to use because we're going to measure the potential difference between here and here. It's a comparison. It's an energy comparison between these two sides. So all we need to do is connect one side of the voltmeter to one side and the other to the other. We don't need to open up the circuit, right? And then we it compares this side to that side. Now, if you take a look at this, a voltmeter must have a very high resistance, because we don't want current flowing into the voltmeter. Because again, this circuit started off its day where it only had one path, and the current would go around, go through the filament, out of the filament, out of the battery, and it'd go like that. When I connect my voltmeter, I want it to continue to do that. I don't want any of the current to go into the voltmeter because that will change how the circuit's behaving. More current will be drawn from the battery than would normally be done, and it changes how the circuit's behaving. So an ideal voltmeter has an infinite resistance. We don't want charges to go into a voltmeter. Now, in reality, a real voltmeter doesn't have infinite resistance. It just has very high resistance compared to the thing it's measuring. But an ideal voltmeter will have infinite resistance, so no current will travel into it, and it won't affect the behavior of the circuit. All right. And here we have our voltmeter connected. We have our battery drawn like we normally draw our batteries with schematics. Here's our light bulb, and we have our voltmeter attached across the light bulb to measure the voltage. Now, the analogy isn't as great for voltage with the water circuit, but the voltmeter might be like a comparison if you had a pressure meter on this side and a pressure meter on that side and compared the pressure drop. That might be kind of like what a voltmeter does.
Extreme. Fair zone.